Another draft physics video presentation. Commenter. They're samples of what's in the world. So you have to deal with these samples, these representations of the simple-minded. Yeah, the dupes, the glib, the I'm not going to think about it very muchers who just go along and spout crap because some piece of jargon, like the Fed did it, 9/11 was an inside job. I mean, they'll just believe almost anything. As long as enough people are saying it, they'll say it. Alright, so I've made the simple point that the evidence does sort of suck for the micro universe. The tiny universe just doesn't let us see too much directly. So we have to see things very indirectly. Even seeing is a very indirect process, where photons have to hit electrons, and the electrons have to move in a specific way to create something called electricity that can stimulate the neurons in our brain. There's no real way to see the process, to visualize it, except to model it. Alright, and so this is not the kind of trial where you're going to have all this direct evidence, videotapes and DNA and, webcams and all that kind of crap. It's got to be deduced based on a bunch of circumstantial evidence, evidence that is a byproduct of it happening. And that evidence is pretty hard to shape into a form where you can say, yes, it's certain beyond all reasonable doubt, blah, blah, blah. Let's be arrogant and obnoxious and tell everybody they have to believe. No, they don't, is what I'm arguing. And I'm arguing that the evidence is really bad circumstantial evidence. It's not even good circumstantial evidence. It relies on a theory that, in many ways is just silly. Frankly, I don't see how it can be defined as anything else but on the silly side of reasonable. Alright, anyway, you just don't have enough evidence. So the argument I'm making is the evidence does, for all of us, kind of suck. It'd be really great if we had really great evidence, but we don't. The experiments are not conclusive, and a lot of them are so convoluted, so complicated, that you really can't depend on there not being any wrong assumptions in the chain of reasoning. So it would be best to have nice, solid, hard evidence for something, but we don't have that, and so then it's perfectly legitimate for the counsel, the lawyers in this process, the advocates, to, especially when one of them's being all pretentious and arrogant, like they've proven something, to point out how, no, there are alternative explanations, and, okay, your explanation is silly. It's dependent on stuff that we have no good reason to think is how the game works. Anyway, not consistent with the rest of the universe we see. Alright, the thing is that you won't accept any, see, this is just more lies, I'll accept evidence. That is, experiments. Experiments are great. Okay, but when you tell me you're going to do something in an experiment and there's no demonstration that you can do that, that's a little bit pushy, right? So if I shoot a photon over here, one single piece of energy, and you tell me that 8 meters over here you're going to detect the same exact photon in a stream of a billion of them, I might say, how do you know you can do that? Isn't that pressing or pushing credibility a little? Like gravitational waves, for example. Well, we can only see them because we have engineered physics to say it's possible, by saying something kind of ludicrous, that matter is converted into bent space, even though our old conservation rule said you can't do that. You either you got matter and you have energy. You don't get to make bent space. That's just sort of bullshit. And not sort of bullshit, it just is bullshit. So anyway, the thing is that you won't accept any academic papers. Alright, so it's a lie, but I mean clearly you're saying I should be convinced by experiments that have so many assumptions and presumptions in them. Again, I can just go back to the jail bar example. You could face the jail bars, and we could have a frisbee, and it could sort of be an IQ test, right? Like kind of like playing tic-tac-toe, where I can say, I already know the answer. I know how to cheat you. So I could walk up to some idiot on the street and say, let's have a contest, throwing frisbees through jail bars. And I bet can get more through than you and blah, blah, blah. And I pick, doing this, the blocking thing, because I know that mine are 100% guaranteed to be blocked, if I throw them this way. If I throw them this way, though, he won't be able to get them all through, because some of them are going to hit the bar. Even though it's going the right way, it's going to hit the bar. So there's going to be an inequity in the two outcomes. It's not 50-50. So I'm just saying, I can point out little assumptions that are in their physics. Those assumptions are, wrong. Too casual in their thinking. And so they've been sort of incomplete and imprecise in their understanding of the functions. And I'm saying they've made lots of mistakes like that, because they have these generalities. They've made these statements as draconian facts about how things work. Their atoms have swirly electrons, this. They have a whole theory based on it. And frankly, they never did any, they never got enough evidence for that first conviction. All right. Let's see. Anyway, because they are unrealistic or fake. So again, that's, you're quoting those words. In what context was those words made? Where did I say they were fake? Where, liar? So again, you have no integrity, because you can't make an honest argument. So again, I like experiments. More the better. I wish they would have done all these other ones I've pointed out. I mean, your physics claims that, these photons are spreading all over the place, infinitely, the angles. So just put photographic film on the two sides of the slit experiment and collect all that light that's supposed to be going over there. Prove your point. Prove that there's enough of it to defend your mathematics. Because I'd claim there's not going to be enough of it. Because you have in fact run out of electrons. There's only so many electrons in the path, and there's only so many little bars of light you're going to make. Okay, they're unrealistic or fake, so why should anyone bother? The paper I presented you wasn't meant to show how well theory agrees with experiment. Well, again, you're using it as an argument that you have demonstrated or proven something, and you haven't. That evidence especially, sucks. It's not even allowed in court kind of evidence. It's so fetal and immature and unfinished and incomplete and indecisive that it's just so wishy-washy that, yes, the judge should say, no, you got to do better than that. That's not really an example of anything being proven. Again, like your buckyball example, right? I mean, it's your theory. This is what you're defending. You actually think that 50 atoms of carbon are faced with two slits, and the 50 atoms of carbon create two copies of themselves, all right, go through both slits, turn into something called a wave function, okay, and create an interference pattern. Now, does your theory also say that when there's a single slit, okay, the buckyball, what does the buckyball do then? Does it create a second buckyball? Okay, two little wave functions, to create an interference pattern. So where's the buckyball single slit experiment results? And if it doesn't, why doesn't it? Because all the other stuff does. The photons do and the electrons do. They create an interference pattern, not a diffraction pattern, not a spreading pattern. No, they create actual locations where there's light and dark, an interference pattern, not just a blob, but a pattern of on and off. So why don't you explain why buckyballs don't do that? Oh, and let's see, by the way, the buckyball you're saying has a frequency of what kind of frequencies does it have? Like, 76 gigahertz or something? I mean, you give it a fake frequency based on its momentum or its mass, right? So the bigger the object, the heavier the object, the smaller your slit has to be. I don't even understand how you get the buckyball through the slit. By your theory, by your mathematics. But again, you don't respond to a single thing I say. So the points I make, you just ignore and pretend they haven't been made and don't bother answering them. So anyway, but that you can see a diffraction pattern with interference on a single slit with electrons. So again, you're saying the experiment has veracity. That they've proven it. They didn't prove anything. The experiment is what it is. I mean, it's junk. It's so bad. And you're saying it's evidence of a diffraction pattern. No, it's an interference pattern. Again, where do you have the right, okay, to say that when you're creating these on and off patterns, that now you're going to say that's diffraction? Because it's not the definition. I think it's disgusting that you wave nuts think you own the word diffraction. That is the idea that something spreads evenly, or even unevenly, lighter, more intensity here, less intensity out here. That process of something being spread is something you own as a wave function. When lots of things do it, and it's called refraction when it's inside a medium, and you're just saying, well, when it's not in a medium like air, something questionably a medium or empty space, let's say, that somehow now this belongs to wave mechanics, when all it means is that if I do the experiment 700 times, 1 out of 700 will go here, 1 out of 700 will go here, 1 out of 700 will go here, they'll spread out based on a probability. That's diffraction. So you're going to call this diffraction now? But so you're just saying screw vocabulary. The two things are two different things. The spreading is one thing. The interfering, the creating of constructive and destructive is a different phenomenon. You can't call that diffraction. All right. Okay. A diffraction pattern can be a Gaussian curve. But it can also be a wavy pattern. No, it can't. So again, that's just bullshit. There's no theory for that. You have to have the interference to create the destructive part. So don't pretend you can get away with that, but you can't. There's no theory for it. We won't be able to show me any diagram of that. Where crests are due to constructive and troughs are due to destructive interference. So again, you're talking your stupid wave jargon as if somebody must accept that a photon is a wave, that an electron is a wave. It's some kind of waving thing, even though every experiment indicates it's a discrete bit that has charge and that functions in an atom as a discrete bit. Now, you say it doesn't have any implication, you say all kinds of mush about the qualities of this thing, but we certainly know that a buckyball is not a wave. It's not waving anywhere. It's not over here and over here and over here and all this other crap. It's really not. Okay, but it can also be, okay, well, that's just nonsense. The latter is what you could see on the linked paper. Well, again, I looked at the linked paper. I read enough of it to know what is this nonsense. I mean, really, you think you can control electrons on a circuit board? That you could, when we know how complicated it is to create, X-rays and the tubes you need to create any kind of flow in electrons, and you think you understand enough about those mechanics on that scale to tell me that they created an electron emitter and an electron receiver? Get real. Okay, but just keep denying. Yes, I'll deny that paper. I'll deny that that's good science. That good science means you do these insanely complicated experiments based on all kinds of wacky assumptions built into them, and that I should sit there and say, gee, yeah, I really trust those results. No, I don't trust them at all. Electrons are repelled by electrons. The smaller the experiment you make, the more likely it is you're just going to have electrons that are going to just move because there's other electrons right next to them, and the other electrons are going to bother them. They're charged elements. You can't do experiments on charged elements in a field covered with charged elements. Doesn't make any sense rationally. All right. The math in QM does describe the vertical lines. So here we go again. Why don't you lie some more? Okay, my argument isn't that your math doesn't come up with vertical lines. My argument is that in all these experiments, the same theory is supposed to be at play, which means the pattern should be the same. Now, I've already pointed out how Newton's rings, in an interferometer, for example, or in thin film interference, these rings are decisive. Well, they're not even to proportion because the little dark rings are much smaller than the bright rings. But the bright rings are consistent. Okay, there's absolutely no, get brighter, get darker, get brighter, get darker, get brighter, get darker. None of that at all visible. Now, I would argue that 99% of the optical with visible light experiments, they're pretty decisively bars of light. All right, very little gradually on, gradually off, and electrons are gradually on, gradually off. So how does the same mathematics create two completely different patterns? They're not the same pattern. And then again, in the two-slit experiment, you have two patterns. You have little blocks, okay, and then you have little blocks in the block. You don't have any wave theory for that. It's certainly random. And then, as I've pointed out, a diffraction gradient, which is a bunch of little lines, a bunch of little slits, sends complete images of whatever you put in here. The complete image goes here. The image, the image, the image. It can't possibly be random, okay, where the photons go, because they create an image at each location of whatever I put in here. I put a star in here, I'll get stars here, okay? I don't remember how to draw a star. Close enough. It's one of those evil stars. You have no explanation. Your theory doesn't account for that. The facts don't add up to you being correct. There's something wrong with your theory, and you're pretending it's unassailable. You can't possibly doubt this loop-de-doo silly notion that something heads for a slit and all of a sudden decides it has to split into two functions of some kind. There's just no evidence of it. There's no reason to believe it. There's a mechanical cause. It actually does matter where the photon goes through the slit, quite obviously, and you can see it in the polarization film. Will show you that fact because the polarization film is also another thing of bars, and it's kind of clearly showing you that it's different. What happens when the pieces of the photon hit the bar is different than what happens when it hits the open space. The two things create a different result. And so it matters where it goes through. It matters what its location is. Because it hits one place, it does one thing. It hits another place, it does another thing. And that's back to this idea that there's slits. And it matters. If the photon goes next to the surface, it's likely to encounter a field of energy that's quite different than the field of energy here. The field of energy here is going to be different than the field of energy here because this surface is covered in electrons and this surface is covered in electrons. And again, this perfectly explains why, well, I send photons through, I get one kind of pattern, bars. I send electrons through, well, yeah, electrons hit electrons and they bounce off each other's fields, so they're very fudgy in what happens. They don't interact the same way, where an electron absorbs a photon, moves a Feynman diagram kind of perfect direction, and then re-releases the photon. So that's an understood process of being kind of precise. But when an electron hits an electron, yeah, the one electron could be here and the other electron could be over here, and their fields are going to affect each other. So they're never going to really hit each other. They're going to bounce off each other's fields. So yeah, they could end up creating a much blurrier line because it's a lot more ambiguous. And then if I send a buckyball through and it hits an electron, right? Okay, it's covered in electrons. This will affect it, and it'll bend it a little, right? It's obviously going to really catastrophically affect the direction of the electron, but the buckyball is also going to be affected. And that's also exactly what the experiment shows, because the pattern in buckyballs is incredibly weak. It's barely a glimmer of a pattern, right? I mean, it's like, you know, I don't know, if you do it with just dots, you know, you'll get a tiny number of more dots here, like, you know, 10% more, you know, tiny, a little 10% more here, you know, a tiny percentage of pattern. It's a very, very weak pattern. And it's because it's a buckyball. It's 50 atoms against one electron at a time. So yeah, you'd expect the pattern to be kind of weak. All right. The math in QM describe the vertical lines. You just don't understand that your first drawing is a probability density. I understand that it has nothing to do with probability. I already explained there's no such thing as probability. Every circumstance is an inevitability. It's just inevitable how I picked up that chalk. Now, to you, maybe it doesn't seem so, but yes, the whole function of my body is a one structure, and it can't change its mind at any one part of the process. My hand moving, everything is programmed. It's going to happen a certain way, and that's just the way it's going to happen. It's not going to happen some other way for any magical reason. If I miss the chalk, or it flies out of my fingers, or you know, some error is made, it'll have a definite, you can see the cause. You can see the cause in my neurology, or because I got Parkinson's, or some other reason. You'll find the reason why. Okay, it's not a mystery. It's not a magical reason. And you want to believe in magic. Okay, understand that you're drawing a probability. Okay. So there's no such thing as a probability density. There just has to do with the fact that variables exist, and the variable for a photon, for anything heading for a slit, the variable that matters is what's your likelihood of hitting there versus there. Each one of these locations will have a variable result. You'll bend more, likely to bend more if you hit on the edge, and likely to bend less if you don't. That's the probability. So you decide the fate of the photon when you decide where it goes through the slit. And as I've stated before, this whole thing could be resolved as soon as we have lasers small enough, that have a small enough point. Just aim them through the two slits, and you'll see that that you can create exactly the same interference pattern. The trick is that obviously we can't send single photons, so the single photon thing is sort of a lie, because it's always going to take a density of photons, because constructive and destructive interference does require you to make a photon out of more than one bit of a photon. So you have to have more than one photon to work with in the first place, or you won't have any pattern at all. You won't have any photons. But even that idea, right? I mean, they talk as if there's such a thing as a single photon, yet we have no physics describing how you can create any such thing as a single photon. All right. Assume that the vertical lines have the same number of electrons on them. So nowhere did I state any such thing. My whole argument is that the electron pattern is gradual, and that the photon pattern, the visible photon pattern, is not. A fundamental problem for you to explain how the same mathematics produces those two different patterns. It's not possible. You can change where the location of the bars are, but you can't change their character. The math is saying something about their character, and you don't use a different math for the two, so therefore you have no excuse for the fact that two patterns don't do the same thing. All right. Assume that the vertical lines have the same number of electrons on them. So that's a lie. Mainly because you're a moron. Well, you're an asshole, frankly. I mean, you're just proving it here. First, you can't accurately paraphrase what I've said and what I'm arguing. Your preposterous exaggerations. You think any experiment published, okay, by popular science, and again, let's understand, popular science wants to believe all this crap. They don't want competing theories. They don't want to have that conversation. So don't pretend they're interested in exposing the weaknesses of their physics. They're only interested in exposing how you should believe in our magical universe. It's wondrous and magical because that sells. All this quantum woo sells to religious assholes. The public. Okay, so you're just a member of the public. A dupe, that's simple. You're just a dupe. Your theory, which is not a theory, so again, it's not how. Why doesn't it fit the rules of a theory? It explains the evidence. It explains why there's patterns, and it does so more completely than your theory. So you're just a lawyer walking in there and say, that lawyer's a fibber. Everything he says is fibby. You don't have an argument beyond that. That's the best you can do, and that's all you'll do. Even in the most charitable sense. So again, where have you shown that? Okay, where have you shown that my mechanical theory for gravity doesn't work, or my mechanical theory for magnets, more precisely, doesn't work? Link me to your well-reasoned explanation of how magnets work. So there must be one video on the whole entire internet that actually explains how a magnet works with actual physical objects, right? You must have such a thing somewhere, right? So why don't you show it to me? Give me a link to that, all right? And I'll drill so many frickin' holes in it, and it'll be fun. And you can't drill a single hole in my theory. All right, can't probably, let's see, the most charitable sense. Can't probably describe the path of a falling object near the Earth's surface without assuming classical mechanics. I'm not assuming classical mechanics. It's sort of been already demonstrated millions of times. We know how the force works. We know, and again, and it's not even complicated. As I've pointed out, it's exactly the opposite of a light bulb. So if you just thought of a light bulb as something that radiates a kind of energy, and you just think of it as being pulled towards energy, like it's a tractor beam instead of it being particles hitting you. So we already know physically that the light has physical pushing power, that it's energy that comes off of it. The photons have energy. They put extra energy in the field, and that extra energy can move very small objects. That's already a proven fact. And I'm just saying reverse it, and that's gravity. It's exactly the same thing. It's exactly the same principle. Not complicated at all. So let's understand that Newton's theory of gravity, it's perfectly rational. It's just that the one they popularize, right, is to do this total force thing. So they do this stupid thing where they say the force equals G, and then they do the M thing, okay, and then over R squared. Well, you don't need this thing, right? If you want to know the Earth's gravity, then you just do the Earth's mass. Or you want to know the sun's gravity, you just do the sun's mass. Okay, and it's always the same proportion. So, I mean, the sun and the earth are in, see, when they do this thing, they're telling you the total force between the two objects. That is, the fact is the earth is a certain weight, okay, and the sun is a certain weight. And we know that the sun is gigantic, though, compared to the earth in weight or mass. And so that the amount of the sun that's going to move towards the earth is only going to be 0.0001%, right? Where the whole earth, its entire mass, will move towards the sun. So it's such a huge imbalance that you never even account for this movement of the sun. But it's really moving, okay? And it's moving as much as the earth is moving. The two things are really moving towards each other an equal amount. They've absorbed the same proportional amount of force. So, but it's proportional to mass. And so the amount that the earth absorbed, the same amount of force is inside of the sun going the same direction. It's just that it's so tiny compared to the bazillions of little arrows. See, the Earth has, let's say, 10 arrows, and so 2 arrows means a lot. This has 1,000 arrows or 1 million arrows, so 2 arrows doesn't mean much. But it's exactly even. Let's see what we did that. Your theory, not a theory, path falling near an object to your surface without assuming classical mechanics. So again, there's nothing wrong with classical mechanics. The inverse square law is the whole point of the whole argument, is that that's how the force is created. Again, you haven't watched any of my videos, right? All right, so I have a playlist called Subjects. You go to that and you look under gravity and you'll find lots on gravity. Because the mechanism isn't that complicated. But obviously the simple argument is that when you have two things, okay, it doesn't matter what shape, we'll just pretend, circular, well, the circular is what creates the inverse square law, so let's play it the right way. And the only argument is that there's energy in the field moving the speed of light, and it surrounds the entire universe, and it's coming from all directions. And every object will essentially feel like the entire universe is pointed right at it, because from every object it's going to be a pressure. This piece of energy doesn't hit this thing. This piece didn't hit this thing. The only stuff that hits this thing is heading right for it. Okay, so everything feels pressurized. And as soon as I put something else in the field, then some of the pressure that was heading right for this little center here, right? This little arrow was heading right for it at the speed of light. Well, if it's trapped in here, pushing this, then it's not going to get here, okay? And this is going to feel that emptiness, that void, and it's going to move into the void. Now the trick is that you have to understand these directions as being components in a direction. And so every impact has a component in this direction, a component in this direction. And so when this effect happens, this absorption, absorbing energy going this way is the same as absorbing a little bit of energy that way. Okay, so yeah, that's part of what gets rid of the aberration problem. Is that the effect, okay, you can take energy away from hitting here, okay, theoretically, by absorbing energy going this way. Because there's a component going that way. Even though it wasn't going to hit here, it's going to still create emptiness in the field. The field's going to be, it's going to interpret it, and so it's always going to be an absence in any direction is always going to feel empty, because inside of the sun there's a bunch of stuff that keeps moving. All right, and so it's like the first time you charge a system up, you have to actually absorb the energy, but once it's charged, then there's equilibrium, and you can't shove any more heat into it. So once you've made something hot as the outside, you're not losing any energy to that object anymore. It's not absorbing anything. But as long as the sun's insides keeps moving, then it has to keep being pushed. It has to keep absorbing energy in all these directions. And that absorption means it absorbed a certain amount this way. Now, this thing can't feel the absorptions that way. So the sun can absorb all the energy it wants to that's going that way, and this object will never feel it. It won't notice it because it can't affect it. And it's only going to sense the absorptions in the direction that it is. And it's going to move into that low pressure. So the argument is that energy is pressure, can be understood as the two things are synonymous. And all you're really doing is looking to what happens to the pressure in a system when I put objects in it. Now, like I said, they probably mechanically have done this experiment to some extent. But the truth is, if you created a box, you can understand this theoretically. And you had little BBs in it that never slowed down. So they reflected and just maintained their momentum. And they're just reflecting, bouncing in all kinds of randomized ways. Not purely random, but randomized, because there's so many variables. And you put two objects, much bigger than the BBs, in the field, that the two objects would, in fact, crash into each other. Just a fact. It's physics. Physics says so. Now, you can call that classical, you can call it all kinds of names because you don't like it, but it's just a fact, a physical fact. It actually happens. All right, here, blah, 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 without assuming classical mechanics. So again, this whole, I don't accept your silly jargon. You want to insult classical mechanics? Go ahead, that's your prerogative. I say it's bullshit. We know that some things, some mechanisms have been well tested by time, and they're reliable phenomenon. I would argue that most of Newton's laws, all of that kind of stuff. I mean, you do actually have to stop something from moving once you throw it into space, something made of matter. But anyway, by interacting with it. You must have an interaction or it's not going to stop. All right. Will your model even allow it to fall? So, you know, here he says, tell me, how much time does it take for a 10G rock to fall 10 meters of height without any starting velocity? Well, it's a percentage thing. Okay, it's like, I think it's 1/2. The equation is 1/2 something something something, but it comes out to like 3/4. So if the force is 10 meters per second, in the first second you're only going to get up to like 7 meters per second or something like that, something less, because it takes time for the force to push. It has to keep pushing things to get them up to velocity. Acquiring acceleration is one thing, velocity is another thing. And acceleration takes time to affect the objects. It takes time for it to hit the fingers and push all the fingers. So it takes time for the force to be absorbed by an object. Your example doesn't explain what altitude we're at, how dense is the air. Yeah, there's lots of factors that'll change how fast you can move something. But anyway, starting velocity. Will your model even allow it to fall? So again, he doesn't even know what Mach gravity is, and this guy's being so arrogant. So it's already a proven theory, Mach gravity. All right, that's this idea of a force from the outside push idea, and it works. Okay, it'll create the illusion, okay, of our normal gravity here on Earth. It does it just fine. Leonard Susskind from Stanford University, one of the most famous Einsteinian physics bullshitters, teaches it. When he explains general relativity, he teaches it, okay, as Mach gravity, fluid dynamics. So clearly consistent with my theory. Will you use the excuse your theory doesn't describe that, so why should I do it? LOL. Well, again, so more quotes that I didn't say, more bullshit on your part, right? You can't write an honest sentence in here. You can't even try. So just more bullshit, right? I mean, you want me to explain on the nuclear, like I said, I mean, I think gravity is a nuclear force. Maybe you have some other delusion about how it works, but you can certainly understand that the density of the field, like the amount of wind you blow on a sail, will change how fast the boat goes. But it's going to take time because the sail is here and it's tied to the rest of the boat by the mast, right? Let's make that the sail. And then you have the whole boat, and then you have the medium that the boat has to get pushed through, right? And all of it has to go through here. It has to hit this, and then it has to be transferred into a pressure on the mast, and then the pressure on the mast has to be pushed into the boat. And so there's lots of reason to say, oh, that's probably going to take a little bit of time, because even at the speed of light, it takes a little bit of time to do that. And so, of course, every object is made of atoms with electrons and protons, and so you can understand that if there was rain falling, that these objects aren't going to fall as fast as the rain, okay, they're much bigger than the rain. They only move a little bit when they get hit by a raindrop. They don't move the speed of light. They move 20 miles an hour, let's say, per raindrop. So, yeah, it's obviously going to take a while for the speed and force of this to get this up to its same speed. And it may not ever be able to get to the same speed, right? Like free falling in an atmosphere, you don't get sped up and sped up and sped up. You hit your terminal velocity and you're done. And it's not because the force isn't pushing you. It's not like it doesn't want you to go any faster. It's just the amount of friction is stopping you from going faster and faster. All right, so what? You think you're doing special magic physics that's way over everybody else? Nobody else can get it or something? I mean, what game are you playing here? So what is your theory? That the force hits a 10-ton object and we're supposed to believe that it instantly goes as fast as the force? The force is going c, the speed of light. Okay, I hit it with one little bit and now the 10-ton weight goes the speed of light because it hit one electron. It made the entire thing move the speed of light. Well, no. Not my theory, asshole. Is that your theory? All right. Even though you believe in classical mechanics. Yes, I believe. What don't you believe of classical mechanics? That would be my argument to you. What do you think Newton had catastrophically wrong? Now, let's not bring up things like, well, he did know the speed of light, and he could have posited the speed of gravity, but he didn't. Okay, so I would argue that's sort of his bad. I mean, he should have assumed that maybe it has the same speed. But anyway, I mean, what is going to be your what are you going to quote from Newton and say that was wrong and you've proven it wrong? Try that. You are simply pathetic. You're a liar, a douche. You can't make a decent argument, and you haven't answered a single one of my questions. You haven't counter-argued to a single assertion I've made about how the inconsistency of your physics. Why does the single slit produce two wave functions? Why is a single object turned into two objects when there's a single slit? Because there's an interference pattern. You have to have two objects to have interference. So why don't you explain how the single object turns into two wave functions. And then explain to me why, when I put those two single slits right next to each other, all of a sudden they still only create two waves. Shouldn't they create four? Can you answer the question, why don't they create four? What's your theory? So Physics Novice posts some info here. Let's see. Here we have some animations by Zohar. Yeah, well, I don't know if they're exactly, but whatever. I mean, look, the gravity argument isn't. I'd like it to be just as simple as we create gravity instantaneously, but obviously the force does move at the speed of light. Okay, it is you can't know something. Like I said, the sun disappears. It is going to take 8 minutes for us to know we're not in gravity anymore. Okay, it's going to take 8 minutes for the absence of the gravitational force to reach us. We're still going to be orbiting the sun that doesn't exist. That's a fact. But also it's a fact that the sun is constantly producing, okay, this imbalance in energy, in the sense that it's consuming energy going one way and releasing energy going in specific other ways opposite to that motion. But it's not, and it's not neither in the same form. Radiating matter, little bits of matter flying off of you, is a lot different than radiating actual light or force. So the energy is trapped in specific ways that are, nuclear, frankly. Anyway, let's see, does it take that into account? Drag problem here, because animation doesn't take into account the stuff that happens in the small universe, right? So I'm just saying, well, it's fine. I mean, it's good to just, you should just point him to mock gravity and just say, well, first you should understand that even Feynman concedes mock gravity answers all the questions specific to gravity. The only problem is it creates other problems that he figured you can't solve, like the drag problem that I've solved. So does he have the drag thing in here? See, I would worry about the CP and S guys because they contrive shit. So you don't need to rework Newton's theory, frankly. It's a perfectly good theory. It's just I wouldn't bother with the MM part. The MM part is a dodge. It makes you think that gravity is one thing happening when one thing makes gravity and the other thing makes gravity. The two things create gravity by existing in the universe, and their gravity is independent of each other. And it's just by, when you put two things near each other, their gravity is going to cause effects between the two of them that are proportional to their mass. But you have gravity even when there's nothing in the universe to fall into it. You have gravity by having size. And the argument is that anything that has any size will become obviously gravitational in the sense that it will get hot. Its center will melt. And that's evidence of its absorbing the force. You won't find anything in the any big thing in the universe that doesn't have a molten core. Even the stinking moon is hot in the center. Okay, that'll be my prediction. They're all hot because they're all absorbing energy to create gravity. It's just like things like an asteroid. They're not big enough to make that obvious. But probably they do have a heat signature that's probably more than just what you can account for from radiant energy reflecting off of them. They probably have a bit of internal heat just from the fact that they are absorbing momentum all the time. All right. When stuff moves, it has to absorb a force to do it. That's the fundamental mechanism. That's the argument to be made, is that everything is dragged. And the fact is, if you want it to keep moving, it has to keep absorbing energy. So, this really isn't ready for prime time, but we'll throw it in here. So I'm playing with a theory of electrons and protons that basically has them as energy trapped inside of what could be thought of as dead photons. So you have a bunch of like dead photons that aren't moving, and that's the membrane. So the membrane is this hard thing, okay, shell. So you know, let's just say you can make the shell out of anything. So there's energy trapped, you know, it just keeps reflecting, and obviously as it would reflect on the inside here, it would tend to reflect to the widest arc and stay in there. So it ends up reflecting energy in these kind of ways, you know, back and forth, back and forth. The energy just keeps going back and forth. And the external world is doing this thing. So, and the only thing that communicates between this and this is changing where this surface is. So if I change this surface, then I change the reflective time. This thing reflects sooner than it should, which means it hits this surface sooner than it should. So it ends up transferring more pressure to this surface, and then this surface bulges out. See, and that's what moves something. So you have to keep, and then it gets dented back again by the pressure equalizes. So the point is that it just keeps pushing, okay, by, you have to keep absorbing energy to keep moving. It only moves one little quanta, one Planck length in space, and if you don't keep hitting it with more energy from one side than the other, it doesn't move. Okay, wrong thing to say. It doesn't move, and we won't bother with that, because again the argument is like if I made a wagon, theoretically, so smart ass Skyraym guy, point out how this is wrong. If I made a wagon in space, whatever, no friction, no bullshit, and I threw energy into it that hits the front end and makes the front end move forward, and that moves the back end forward, right? You can understand, right, that as the wagon moves, the back end has now gotten closer. So the front end is here when the reflection took place. Now when it goes back, it's going to go back much less distance because the back end has moved, and that means it's going to go forward. Okay, when it goes forward again, the front end is going to be here, so it's going to spend more time going forward, less time going backward. You get it? But the motion forward, so all you do is when this reflects and hits the back end, it just stops it from rolling. But then when it reflects back and hits the front end again, it starts it rolling again. And then for the period of time, the arrow's going back, all right, and then it stops again, and then it rolls forward again. Okay, once it hits this front surface, it rolls forward again. So it moves forward on this backstroke. And the backstroke is shorter than the forward stroke. The forward stroke is when it's dead. The backstroke is when it's moving. And so that's exactly opposite. So if I had a field coming in that was pushing against the wagon, it would, in a sense, just the wagon would end up just shortening the distance, but it would still be going forward because it's still the same back and forth. It still has to keep going forward through the opposition. So it would always compensate for whatever amount of drag I'm moving it into, because it just shortens the distance, which increases the energy. So obviously, if I'm right, so here, just point out this, just give me your best argument why this isn't a reasonable explanation. We know charge exists, right? Two electrons repel each other. My simple argument is that's because there's energy bouncing back and forth. Little photon energy bouncing back and forth. It's reflecting. So it's not getting diverted. So if it was the other force, it would divert. It would leak out. It wouldn't exist. But electrons always have this crap between them. And the fact is all I have to do is push them closer together to increase the energy, increase the pressure, high pressure. So this pressure is higher than this pressure because there's the same amount of stuff moving the same speed, and it's doing it in a smaller area, so there's more impacts on the surface, and the impacts on the surface is how you measure the energy. So you're increasing the number of times it's getting hit. So you've increased the energy just by putting them closer together. Now, why can't that work as a model? Explaining why electrons repel and why there's this seemingly increase in energy as I change how close or far away electrons are from each other. Okay. So, enough of a video. What do you think about freeing DC tech? Sorry, you have to speak some sort of, common English. What the hell could that mean? Let's see. None of you really. Of course, there's going to be stuff that's not completely accurate. It's GCSE physics for kids. Well, yeah, right. High school graduates. Not exactly kids. But again, what's the excuse for ever being inaccurate? What, kids can't handle the truth? I mean, so you have to tell them something that's not really true? No, you have to, because they're going to say, what the hell are you talking? What do you mean? It turns into 2? How does it do that? Yeah. Yeah, they're going to ask way too many questions unless you try to, lie. Unless you lie. The reason it has less views and subscribers is because a lot of them are students no longer studying. Okay, well, that's fine. I didn't know how long he was making videos. It just seems rather amazing, right? To have 56,000 subscribers and to have videos that are less than 500 views. Just, it's amazing. It's amazing lack of retention. I guess once his students were done with him, they were really done with him. You just think for old time's sake they'd watch a few videos. Anyway, enough said. Till the next time and such and so forth and whatnot.